All right, welcome to part 2 of 8.3 notes. We are going to start off talking about logarithmic functions. So let's go ahead. We're going to make a subtitle. So let's subtitle this Logarithmic Functions. So we're going to be talking about graphing here, and it's very easy to get confused on graphing, especially since we've been graphing exponentials and now we're trying to graph logs. So the way that I like to go about this is we're going to remember 4 pieces of information, and then we're going to logic to what we need to know. So I'm going to show you how I do this. And this is what I do every time I'm working on an assignment or a quiz or even the test. This is what I write at the top. That way, I only have to remember it one time, and I can refer back to it as many times as I need. So, we're going to make 2 columns. Our first column is going to say graphing exponential functions. Our second column is going to say graphing logarithmic functions. Okay, so I'm going to show you how I logic my way to the information I need. And I do this every time I'm working on an assignment, a quiz, a test. I just write this at the top and I logic through it. That way I really only have to remember it once and I can refer back to it. So I know that an exponential function looks like this. Y is equal to b to the x. And then I remember when we graph exponentials, we're graphing -1, 0, and 1. These are the x values that I'm graphing at. This is what I remember. This is it. If you can remember this, you can logic your way to what we need to graph logs. Okay, so here's what I'm thinking. I'm thinking, okay, -1. So if I plug -1 into this function, b to the -1 power is the same as 1 over b. b to the -1 power is 1 over b. Then let's plug in 0. b to the 0 is 1. And b to the 1 is b. So now I have my points for exponential. How does that help me get to the log points? Well, let's think. So you stay where you are. I'm going to go back into chapter 7. And I'm going to go all the way down to the review. And let's take a look. So in chapter 7, we said find the inverse for each of the following. And we were given a list of points. So we were given 1, 3, 1, 4, 9, 5, and 6, 2. to find the inverse of those points, what did we do with the x and the y value? We just flip them, right? So to find the inverse of a set of points, we're just going to flip x and y. Now, we know that exponentials and logs are inverses. So if I come back over here, I can say inverses flip the x and y. If I know that inverses flip the x and the y, when I graph log points, I must just be graphing 1 over b negative 1, 1, 0, and b 1. Those are the points that I'm graphing. So at the top of every assignment, if I'm graphing, every quiz when I'm graphing, every test when I'm graphing, I just write out these two lists of points. Okay, see how they're so similar? By the end of the test, by the time we take the test, we have so much material that we have to remember. It's nice to have one less thing to memorize. Now, if you can memorize these, that's great. If that works for you, use that. Just memorize it. You don't have to logic through it if you can memorize it. But if you struggle to memorize it, just logic through it like this. Every time I do an assignment, just like this at the top, this is what I write down. So if you have trouble memorizing it, logic it. Now, when we have logarithmic functions, just like what we did with exponentials, we're going to look at kind of our two parent graphs. So let's take a look at our two parent graphs. We're going to just draw sketches. So over here on the left, we're going to draw f of x is equal to log base b of x, where b is greater than 1, just like what we did with exponentials. And then on the right, we're going to take a look at f of x is equal to log base b of x, where b is in between 0 and 1. So for our purposes, it's a fraction. Now, let's think about chapter 7 again. If I go back, when we graphed inverses near the beginning, we said that inverses, we looked at this kind of example of a triangle. And we said if the original is orange, the inverse is yellow. What's happening is we're taking our graph and we're flipping it over y equals x. So if we kind of think about an exponential function and it getting flipped over y equals x, that's what a log is going to look like. Now, when we start graphing these, both of these, we're going to draw a sketch of each. So let's go ahead, we'll draw just a rough draft of each one. And on each of these graphs, I want to have, on the y-axis, we're going to go up 1 and down 1. On the x-axis, we're just going to go over to positive 1. Now, exponential graphs have an asymptote on the x-axis. If I flipped it over the line y equals x, like how we know inverses flip over that line, for logs, we know that we're going to have an asymptote along the y-axis. So we're going to go ahead on each of these graphs, and we're going to draw in an asymptote on the y-axis. And remember, that just means it's a line that our function can never touch. So our function can never touch this line. Now, when b is greater than 1, I'm thinking about those 3 points that I want to graph. So I'm graphing 1 over b negative 1. So 1 over b negative 1 is going to be somewhere down here. So this is 1 over b negative 1. 1, 0 will be here. And b1 is going to be somewhere up here. We're going to draw this like the rounded edge of a corner of a piece of paper. It's going to look like this. Okay, let's look at what if b is a fraction. So if b is a fraction, when we come over to this graph, 1 over b negative 1 is going to be out here. One, 0 will be here. And b1 will be here. We're going to draw it like the rounded edge of a corner of a piece of paper. Okay, so we're going to work on 4 problems. So we're going to graph 4 of these. We're going to start off with 2 basics, and then we're going to do 2 that are a little more complex. So what I want you to do, you're going to go into the content library. Under the 8.3 tab, there's a page that says blank graph. You're going to click on the graph, and you're going to copy it. Oops. Okay, so you're going to copy the graph. Then you're going to come back over into our notes, and you're going to paste the graph. And when you paste the graph, we're going to paste it 4 times. I want you to leave 3 lines in between. So what I mean by that is you want to go 3 lines. And then some space in between each. So it's going to kind of look like this. So you're going to paste the graph 4 times. I want you to leave 3 lines so that we can write out the problem and write some other stuff in between each graph, and then leave a big block of space in between from left to right. Okay, so once you've got it, give me a thumbs up. So thumbs up, I have pasted those 3 graphs in there. 4 graphs in there. Okay, keep your thumb up once you're done. That way I know everybody's done. Okay, so we'll call this example, what are we on? Example 4. Example 4 says to graph and then state the domain and the range. So graph, state the domain and the range. So we're going to do 2 functions that are pretty basic. No shifting, no stretching, compressing, no reflecting. And then we're going to do 2 that are a little more difficult. So in problem A, we're given f of x is equal to log base 5 of x. Now, at the top of every assignment, every quiz, every test, I've already written out this list. So I've already written 2 sets of points. And I know the one is exponential and one is logs. So then when I graph logs, I'm just referring back to what I wrote at the top of my assignment. And that way I don't have to think about it every single time I graph. I don't have to run through this. Write it once, refer back to it. So I'm thinking, okay, so the points I need to graph are on the log list. So those points were this. 1 over b negative 1, 1, 0, and b1. Now, b is 5, so I know that I'm graphing 1 over 5 negative 1, 1, 0, and 5, 1. So there's no shifting, no stretching, no compressing, no reflecting. So I'm going to go ahead and just start with drawing my asymptote. It goes along the y-axis. We have to draw this every time we draw one of these. We have to draw it. And then I'm going to go plot my 3 points. So 1/5 negative 1 is about here. We're going to guesstimate where 1/5 is. It's kind of hard to be accurate, but we're just going to guesstimate. Then we're going to draw on the rest of our points. So our graph should look like this. Okay, then we're going to take a look at domain and range. So I'm thinking domain, I'm checking my x value. So I'm going to use a ruler, but just grab your pen and put it along your ThinkPad. So when I check domain, I'm taking my pen up and down. And I'm thinking, where does my pen touch the orange function? So when x is less than 0, or over here on the left, my ruler or my pen doesn't touch at all. How about right at 0? No, because that's where the asymptote is. How about right beyond 0? Yes, so I know that my domain is x values such that x is greater than 0. Now when I think about range, I'm going to turn my pen, in this case my ruler, And now I'm taking my ruler up and down. I'm saying, where does my ruler touch that orange function? So it touches, and then no matter how high I take my ruler, it's going to continue to touch. Even though it kind of looks like the function levels off, that function is going up forever. It's just going up forever, very slow. So if my ruler touches everywhere, my range is going to be all real numbers. Okay, let's try another one. We'll call this example B. In example B, we're given the function f of x is equal to log base 1/3 of x. So remember, at the top of every assignment, every quiz, and every test, I've already written out these points. I've got two little lists. So I just have to refer back here and look at my log list. Okay, so my log list. So I'm thinking I'm graphing the points 1 over b negative 1, 1, 0, and b1. Okay, my base is 1/3. 1 over 1/3, or 1 divided by 1/3. How many 1/3s are in 1? Show me on your hand. How many 1/3s are in 1? Good, 3. So this is really 3 negative 1, 1, 0, and 1/3, 1. These are the points that I'm graphing. Now, we're not doing any shifting, no stretching, no compressing, no reflecting, at least not in this one. So I'm going to go ahead, I'm going to draw on the asymptote. Goes along the y-axis, and I'm going to go plot my 3 points. 3 negative 1, 1, 0, 1/3, 1. And it looks just like this. Can somebody tell me the domain? So you're going to take your pen up and down, and you're going to check, what's the domain? Somebody brave, tell me the domain. Say it one more time. X is what? Not less than 0, but greater than 0. Because if we take our ruler, the numbers that are less than 0 for our x's are over here. So x is less than 0 is over here, so we want x is greater than 0. Somebody else tell me the range. So if we take our pen, we change it the other way. Horizontally, we go up and down. What's our range? Good, all real numbers. Okay, let's do another one. So we'll call this example C. Now we're going to get into some transformations. So we'll come over, we're going to call this example C. Oops. In example C, we're given f of x is equal to 3 times the log base 10 of x plus 1. So now we've got transformations happening. So we're going to start off just like exponentials. we're going to kind of list out our transformations. So that +1, would we say that +1 is inside or outside? Just for everybody, is it inside or outside? It's outside. So is that up 1 or down 1? Everybody point. Up 1 or down 1? Up 1. The 3, inside or outside? Outside. So is it vertical or horizontal? Is it vertical or horizontal? Okay, it's going to be vertical. Normally, if I multiply something by 3, it gets bigger, so this is a vertical stretch. So it's going to be 3 times as tall. Now, my base is 10, so I'm thinking, okay, those 3 points that I need to graph are 1 over b, -1, 1, 0, and b, 1. If b is 10, I'm thinking, okay, 1 over 10, -1, 1, 0, and 10, 1. So what we're going to do, we're going to start with the shift. The shift says up 1. So I'm going to take my origin, and I'm going to move it up 1. And I'm going to put a star there. So my origin is moving up 1. We're going to put a star there, and then we're going to draw the asymptote through the origin. So shift my origin up 1, put a star there, draw the asymptote. Now I'm going to graph where my points would go before I stretch them. So before I stretch them, I'm thinking, okay, so if my origin is here, this is my new x-axis. You don't need to draw it in. We're going to erase it. Okay, I want you to see it on mine, but don't draw it in. We're going to erase it in just a second. If this is my new x-axis, my 3 points, okay, so I'm thinking 1/10, -1. We're going to guesstimate the 1/10 part, 0, 1, and we're using x's here. And then 10, 1. 10, 1 is going to be a little off the graph, so we're going to extend our graph. Because our graph only goes to 9. So we're going to extend our graph. We're going to call this 10. So then 10, 1 will be here. So just extend our graph just a little bit. Our graph is only over 9. Now, when we say vertically stretch, we're saying based off the pink line, based off of our new x-axis. So my first point right here, this point right here, how tall is this point based on the pink line? How tall is it? Nobody has a guess. How tall is it? So from the pink line, how many down is it? The first point that is circled, how many down is it from the pink line? Show me on your hand. It's down 1, which means it's -1 tall. So -1 times 3 is -3. So I need to bring this point down to -3. So I'm vertically stretching it. It was -1 tall times 3 is -3. Now, our next point right here, based on the pink line, how tall is it? Show me on your hand. How tall is it? Not a trick question. Should not be hard. So if it's sitting on the pink line, how tall is it? Good. It's 0. So 0 times 3, still 0, so this point doesn't move. Then this point right out here, based on the pink line, how tall is it? Show me on your hand. Good, it's 1. 1 times 3 is 3. So we're going to bring it up to 3. Then we're going to draw this. Let's take a look at our domain and our range. So my domain, so I haven't shifted left or right, so my domain is still x value such that x is greater than 0, and my range is still going to be all real numbers. Okay, let's take a look at another example. So we're going to call this example D. This is the last graphing problem we're going to do. So let's call this example D. In example D, we are given f of x is equal to 1/2 times the log base 1/4 of x minus 3. So we're going to go through that same process. We're going to list out our transformation. So I'm looking at the -3 and I'm thinking it's inside, which is telling me left and right. It's going to do the opposite of what I think. So it's going to go right 3. The 1/2 is outside, which means vertical. Normally, if I multiply a number by 1/2, it gets smaller, so this is a vertical. It's going to vertically compress our graph, which means it's going to make our graph shorter. Okay, and those are the two transformations. Now let's think about the points that we need to be graphing. So the points that I need to be graphing are 1/b -1, 1, 0, and b1. So if b is 1/4, 1 divided by 1/4 is 4. And then 1, 0, and 1/4, 1. Okay, so what we're going to do, we're going to start with the shift, just like exponential and just like the last problem. So we're going to go right 3. We're going to shift the origin, right 3. 1, 2, 3. I'm going to put a little star there, and I'm going to draw the asymptote. Now I'm going to go put x's where my points would go. So based on this being my origin, my points would go at 4, 1, 1, 0, and 1/4, -1. So these are where my points would go. So I'm using x's because these are not my final points. I still have to compress this by 1/2. I gotta make everything half as tall. So based on the x-axis, how tall is this point? How many down is it going from the x-axis? Show me on your hand. Good, it's going down 1 from the x-axis. So half of 1 is a half. So I'm going to come in and make this half down 1/2. Instead of down 1, we're going down 1/2. Okay, this next point, based on the x-axis, how tall is it? Show me on your hand. Very good, it is 0 tall because it's sitting on the x-axis. 0 times a half is 0, so it stays. The next point right here, how tall is it based on the x-axis? Show me on your hand. It's 1 tall. 1 times a half is 1/2, so we're going to bring it into 1/2. So we took our graph and we smushed it. We made it half as tall. It's like we put it in one of those, what do you call those, compressors. Okay, so we took our graph, we made it half as tall. I'm going to go ahead and get rid of these little x's. And I'm going to draw it in. What's up? Is it supposed to be going the other way? Yes. Because I meant to do, what did I mean to do? Let's redo this. So I meant to graph what points? Good catch. So the points we meant to graph are 4, -1, 0, 1, and 1/4, 1. Now we're going to make everything half as tall. So now when we make it half as tall, it's going this direction. Okay, let's think about domain and range. Domain has now changed because we've shifted. Domain is now x value such that x is greater than somewhere. X is greater than, show me on your hand, what number? X is greater than, where's our asymptote at? Good, most of us have it. X is greater than 3 because the asymptote is at 3. And my range is still all real numbers. Okay, so we're going to do a lot of practice graphing in between now and the quiz. But for right now, we're going to move on. We have one more small topic to cover about logs. Okay, so we're going to move on from graphing. So we're going to come over, we'll call this just right below our graph, we're going to call this example 5. Example 5 says, write an equation for the inverse. Inverses, that was a chapter 7 topic. Okay, so in chapter 7 we said, all right, there's really just 3 steps to find an inverse. So from chapter 7, there are 3 steps to find an inverse. 1, 2, 3. Does anybody remember step 1? So let's think back. Anybody remember step 1? That's step 2. So step 2, solve for y. But step 1 is Very good. Switch x and y. So switch x and y, solve for y, and then we're going to call it f inverse of x. And remember, that's not a -1 exponent. It's just a notation for the inverse. Okay, so we're just going to do 2 of these. They're not very hard, so we're only doing 2. And we're just following these 3 steps. 1, 2, 3. So example A, we are given y equals 0.5 to the x. Now, let's think about this. Is this a log or an exponential? Is this a log or an exponential? Is this a log or an exponential? Give me 1 for log, 2 for exponential. Okay, it's an exponential. It doesn't have log anywhere in there. So I know the inverse of an exponential is a log. So my answer is going to have log in it. So let's go ahead. We will start with step 1. Switch x and y. So I'm just going to switch their places. Step 2, solve for y. Well, y is trapped as an exponent. How do I get that y down from there? Well, to get the y down from there, we're going to switch forms. So I know in exponential form, I have a base raised to an exponent equal to an answer. So I know in exponential form, I have a base raised to an exponent equal to an answer. Now when I write this as a log, all I'm going to do is unscramble the letters to be B, A, E. I want to put them in that order. So this is going to be log of 0.5 of x is equal to y. So all I'm doing is unscrambling them, rewriting them in the order B, A, E. And then I don't want to say equal y for my final answer. What do I want to say? Equals, what am I calling it? F inverse of x. So we're going to call it F inverse of x. Oops. Okay, let's do another one. Next one, very similar. Y is equal to 10 to the power of x minus 1. Okay, so this is an exponential, so I know that the inverse will have a log, so my final answer is going to have a log. I'm going to start by doing step 1. Step 1 says switch x and y. Now I need to solve for y. The y is trapped as an exponent. Because it's trapped as an exponent, I'm going to have to change forms. So I know that in exponential form, I have a base raised to an exponent equal to an answer. So when I switch to a log, I'm just unscrambling this to be in the order BAE. So this is going to be log base 10 of x is equal to y minus 1. Now I'm currently in step 2 of finding inverses, which says solve for y, get y by itself. Well, y is not by itself yet, so I'm going to add 1 to both sides. So this is 1 plus log base 10 of x, and we're going to call it f inverse of x. So the inverse of an exponential, which is what we started with, is a log, which is what we ended with. Alright, this is all I have for you for 8.3 Part 2 notes. As always, if you have any questions, feel free to email me or watch this video again.